So this is a typical question from KNEC, Kenya National Examination Council, for students for diploma in mechanical and then automotive engineering, module 3. So the question asks that you have been provided with the orthographic view of a shaped block. So you are required to come up with an isometric view of the same, with V being the lowest part. So in our case, you can be able to see this is P. Now we need to examine this drawing and then be able to draw it. In our case, you're going to use AutoCAD. Sometimes for students it is not easy to see the diagram, but at the end of it all, we expected to see something like this. Now this is the drawing. So this is isometric drawing. Already you have converted the orthographic view to isometric drawing. So we need to remind ourselves a few things before we can proceed to drawing it in AutoCAD. One is that orthographic projection is a way of drawing a 3D object from different directions. There are usually two methods. The first one, we call it first angle method or third angle method. So in showing the orthographic projection, you usually have the front, side, and plan views. Now depending on the side which the observer is starting from. Then the other thing is, we also need to understand that isometric projection is a method of representing 3D objects in 2D objects. So usually the isometric axes, they are usually 120 degrees apart. Now to be able to see that well, so here we have an isometric object. So from here, so if one is starting here where my cursor is, you can be able to see you can be able to observe the various views of the diagram or the object. So we can get to see the front plane, we can get to see the top plane, or what we usually call the plan, and also we'll be able to see the side view. In this case, we're able to see the light plane. So it is worth noting that from the front view, we can be able to come up with a few dimensions. We can be able to see the height of the object. So this is the height, and then also it provides us with the width of the object. So front plane provides us with the height of the object and the width of the object. Now from the side view, we can be able also to see the height of the object and also the depth. So this is what we are going to call depth. Then on plan, we can be able to see the depth, and then we are able to see the width. So you need to understand these diagrams, so that will make it easier for you to understand the questions. Now in our case here, the diagram given, so this is the front view, this is the plan, and this is the side view. So we have said that the side view can be able to give us the depth and the height. So the depth of this object is plus 34 plus 8, which give us 50. The height we can be able to deduce from the front view. So from here up to here, it is 20 because we have been given the radius of 20. Then we add 30, we add 13, and then we add 12. So that gives us the total height of the object, which is 75. Now, still from the front view, we are able to get the width of the object. So it is 13 plus 30 plus 12 plus 45, which gives us a total of 100. Also, it has been calculated here. You can be able to see that from this edge to this edge is 100. Also, similarly, we are able to get the depth of the object by looking at the plan. So here we have between here and here is 8, then 17, and this diagram seems symmetrical. So 18 plus 8 plus 17 give us 25, then you multiply by 2, you get 50. So this gives us the depth. which we were able also to get from here. So this information is very critical because it is going to help us to draw the drawing that we need. It's going to help us to come up with an isometric view from orthographic views given. Now, there are two methods of doing this. So we have what we call box method, and then we have what we call offset method. So offset method, in this method, you're required to come up with an isometric view. You need to select the side, the length, and the breadth of the object, and then you draw parallel to the isometric axis that you already have. You're going to be able to see that later. Now, for the purpose of this class, we are going to use box method. So this box method, it is easy and intelligible way of converting or transforming orthographic views into isometric views. However, it takes a lot of time, but for a starter or for a beginner, it is a good method because you're going to be able to see how you're able to come up with isometric objects from orthographic views. So in this method, we need to obtain the maximum length, breadth, and the height of the object. Then these dimensions, you're going to represent them according to the isometric projections, as you're going to see. Yes. Now, in this case, if you were to draw a box showing the maximum length, breadth, and height of the object, then you would have something like this. So this will be the front view, where we have the measurements being 100 by 75, that is height, and then also 50 by, which is width. So from there we are going to proceed now to AutoCAD. Instead of using paper now, we're going to use AutoCAD to be able to come up with this. We are going to open AutoCAD. So this now is the AutoCAD interface. And now to be able to come up, to be able to draw the isometric drawing, we need to do some changes, to do some setting. First, we need to change the snap setting into isometric. So there are two methods that you can be able to do that. You can come here, then go to snap setting, then it is in, you can put it on here, check it on, so the spacing is light. Then from the snap type, we will use the grid snap, and then choose isometric snap. And then from there, we'll be able to place OK. Also, you can be able to use command where you like DS. So DS, and then you say enter. Then it will be able to give you the same window to allow you to draw the isometric drawing. Second thing that you need to do is we need to turn the ortho mode on. Ortho mode on. You can as well place F8. F8. Yes, so F8. Then you're going to use to select here from the isometric drafting, you can be able to use to select the isoplane that you're going to use for the drawing. Now first we are going to use we are going to draw our box, so depicting the maximum height, length, and also the depth. Yeah, and that's that. So I have been able to draw my box here. So now the next thing is, so here the dimensions, this is 100, this is 50, the height is 75. Now I'll need to now draw the diagram, and since I don't have it, so I can attach it here on the screen so that I'll be able to see it. So I'm going to write a command, image attach. Then I'll be able to select it. I've stored it, the diagram, my orthographic views are in the desktop, so I'm going to select it there, and I'm going to open. So I'll say okay. Then I'm going to show where I'm going to place my drawing so that I'll be able to see it there. Now I can be able to I want to align this one, so I want to select it. But even after looking at this view, we are not able to determine which view is closest or farthest. So all views must be studied to analyze the shape of the object. Now, from what I can be able to see here is that after observation, I can say this may be a wheel. So if I look at this top, so this is part of a wheel, then it is symmetric on the other side. Then this one, given that here is blank, and here is where there is a hidden line, so it means this circle is part of here. So we are going to, this surface belongs here downwards. Then we can be able to see that since this, the side view, maybe it will start appearing from this. So I want you to pay close attention on how I'm going to move these items. We're going to delete other lines so that you'll be able to see how you're able to come up with the object. From here, it is easy to see the object as it is. So now you require to move different parts. You're going to delete, you're going to modify, and then you'll be able to see. So let's get started.